The day after school.
All right. One. You said how many solutions?
One.
Yeah. That's right there. One solution. It's really one root. The term solution is overused. What about number 2? No roots. And again, it's none because why? No x-intercept. And number 3? 2 roots. So one right here and one right here. Not asked to figure out what they are, just how many there are. So 2 roots. All right. So, and again, it's such a misnomer to call it solutions because it all depends on what you're asked to solve. You know, so how many roots or zeros? And the race is on. All right. So, very important, folks. The term roots, you know, it's kind of an iffy term because, you know, anytime you have a word that means more than one thing, I guess paying attention is optional. That was sarcasm. We'll get there eventually. Yeah, roots could mean more than one thing. So in this context, it means the x-intercept. So it's memorization. The term zeros, also synonymous with roots and x-intercepts, I think it tells you more because it's indicating for us the values for x at which the graph has, as a result, equal to 0. Right? So basically, if I were to plug in, you know, if I were given an equation, if I were to plug in an x value, in this case of 3, it looks like, the result after evaluating would be equal to 0. Right? So we call those the zeros of the function. It also turns out that if the value of an equation is equal to 0, that places it on the x-axis. Right? So that makes it coincide with the concept of an x-intercept. Right? So out of all of these terms, I would think that the term zeros would probably be the most important. Right? They don't use it too often on this level, but what they'll do is they'll kind of slip it in on a problem on the Regents exam, and that can be pretty frustrating if you've learned the word roots or x-intercepts all year long, and the question asks you all of a sudden to find the zeros of a function on the exam, and then you look at it and you say, I don't even know what this question's asking, and then only to find out later on that it was asking you to find something that you always knew. You just didn't know what the word represented, right? So it is a memorization piece where you have to train yourself to think x-intercepts, roots, zeros, they all mean the same thing, right? So what do? I'll put it on a quiz. I'll put it on a test so that you have experience with it, or a problem set so that you're not shocked when you see it on the Regents exam, all right? Anyway. So number 4, Erica partially solved some quadratic equations using the quadratic formula, and the following were her results. How many solutions does each one represent? I said A was the obvious one, and the reason for that is what? Why did I say that was obvious? Because I'm being a wise guy? Sometimes. Not this time, though. Because it has a negative under the radical, yeah. That negative under the radical is telling us that there are no real roots. We learned about a topic in the last unit where we talked about the type of roots. Does anybody remember what that topic was called? Hint, it's on the board, it's on your handout. Discriminant. All right. Does anybody remember what that formula is? That's the challenge, I guess. I heard elements of it. Someone might have actually even said it. B squared minus 4ac. Good. B squared minus 4ac. Now, that's the thing, just as a refresher, It's the thing that's under the radical. I'm actually just going to write that. The thing under the radical. But specifically in the quadratic formula. All right, so the thing under the radical in the quadratic formula. All right, and that's the thing, you know, when I was grading the tests in the last unit, it's a little surprising because, you know, I gave you the formulas, so if you just know that the discriminant is the thing that's under the radical, it's not a new piece of information that you need to memorize, you just need to know what to look for. All right, so the discriminant gives us certain particular, or gives us particular values. Those values dictate what type of roots you have. Right? If you got a negative discriminant, in this case the discriminant was a negative 80, it tells us that we have no real roots. All right? But you could also do the computation. You try putting that in your calculator, it'll very clearly tell you. Not real. Non-real, I believe is what it says. You try to type it in. I mean, you can't put plus or minus, you gotta do it one at a time. But type in 4 minus the square root of negative 80 over 6. It's gonna give you an error message. It's gonna tell you that you have a non-real answer. Right, so that's your indicator that there is no solution. All right, this one you could simplify a little bit more. And this is assuming that you don't have instant recall on all of those rules. You split it up, you get 24 minus 12 over 8, or 24 plus 12 over 8. But the idea here is we're going to get how many answers? 2, right? So we're looking at 2 real, specifically rational roots. All right? Now, it's asking us how many solutions does each one represent. So do I need to include real and rational? No. If I just say 2, that's fine for this particular question, but you want to kind of build your knowledge base. You want to reinforce the concepts from the last unit. And you never know, down the line, I might merge the concepts together, in which case you'd want to save it this way.
Is it possible to have more than 2?
Not for a quadratic.
Wait, can you explain what the discriminant is again in relation to the problem right here? Because I don't understand this.
The discriminant is the number that's under the radical. So if you were to compute b squared minus 4ac, if you were given a quadratic equation and compute b squared minus 4ac, you would get these numbers under the radicals. The types of numbers that you get dictate how many roots you have. If it's negative, it's imaginary and therefore no real roots. If it's a perfect square, a positive number that's a perfect square, then there's 2 real rational roots. If it's 0, you see this one, 0, simplifies down to just 9 over 3, right? Specifically equal to 3. How many roots is that? 1. So we're looking at 1 real rational root. So if the discriminant is equal to 0, you're looking at 1 real rational root. All right? Part D, you could simplify that a little bit, but are you ever going to be able to simplify away the radical? No. All right? How do we know we're not going to be able to simplify the radical away? It's not a perfect square. All right? So if it's not a perfect square, we're going to get a radical in our final answer. What kind of numbers have radicals in their final answer? Irrational. All right? So we're going to have 2 real irrational roots. All right? And that's because the number under the radical, again, also known as the discriminant, is not a perfect square. It's positive, but it's not a perfect square. All right? These are all memorization pieces, but you can see it in action if you had an equation to work off of. In this case, we don't have an equation, but we're moving towards that. How can you help Erica determine the number of solutions without actually finding the solutions? All right, well, let's kind of beat that to death a little bit. Find the discriminant. compute b squared minus 4ac and determine if our four possibilities, right? We got positive and a perfect square, positive and not a perfect square, negative, just negative in general, or the other possibility, 0. All right, if it's positive and a perfect square, then we're talking about two real rational roots. Positive, not a perfect square, two real irrational. Negative would be no real roots. And 0 would be one real rational root. In case I'm not being clear enough. Hold on. I'm really going to drive this point home. Know those facts. All right, so in number 6, what we want to do is take a look at what we got in number 4 and compare it to the graphs and see which ones could go along, which partial solutions could go along with the graphs that were given. All right, so which one would go along with the first graph? Which partial solution, A, B, C, or D? C. So 1 and C. What about the second one? D? A. And what about 3?
2D. 2FB.
3 and
3 and B.
3 and B? Yeah, the tricky one was number 3 because that could go in 2 possible directions. It looked like it most likely was going through a clean point, 1.5, 4.5. But if it's slightly off from that, maybe it is an irrational number, in which case you go with the radical one. All right, so just be careful with a question like that. But if it doesn't cross the x-axis at all, it's no real roots. If it crosses only once, that must mean your discriminant is equal to 0. All right, these are relationships. Unfortunately, we don't want to always have to memorize things. Sometimes you just want to see a concept, internalize it, and then just make use of that concept and not have to memorize facts. But sometimes it becomes a situation where you do have to memorize things, and this is one of them. Moving right along. So again, let's see if we can remember it from the previous page. I gave it to you. Let's get it all down. You tell me. B squared minus 4AC. All right. So that discriminant can be used to determine the value of real solutions, or the number of real solutions to a quadratic equation if we have a positive discriminant value. Because really, let's just kind of streamline it. We're looking for number of solutions. How many solutions would we have if we have a positive discriminant? 2 solutions, 2 roots. All right, they could be irrational or rational, but there will be 2 of them. All right, negative? None. And then 1. All right, very good. All right, so next little section, state whether the discriminant of each quadratic equation is positive, negative, or equal to 0. Then match the graph with the corresponding discriminant. All right, so taking a look at number 1, we'll worry about matching it in a second, but we're going to state whether the discriminant is positive, negative, or equal to 0. So in the case of number 1, equal to 0. All right, and that's because there's one root. All right, in the case of number 2, it's going to be negative. Number 3, positive. And what about number 4? Positive. All right, so now we do have to match it with the appropriate discriminant. All right, so a little bit of computation. So A, are we looking at a positive number or a negative number here, or something equal to 0? Because again, we don't care what the number is, we just care about what kind of number it is. Positive? Negative, right? Because it's 4 minus 8. So smaller minus bigger, it's going to be a negative quantity. And as you move forward, you'll see that we don't always care about what kind of, or what the number is. We care more about what kind of number it is. So A goes with 2. All right, because we already decided that we were looking for a negative discriminant for the second graph. All right, what about B? Yeah, some dissenting viewpoints here. I heard a 0 and I heard a positive. 0, right? So we got a 16 and a 16, right? But this one's going to be negative because there's 3 negative signs. So 0's out. So the one that has a 0 is
1.
numero uno. All right, so let's actually compute the value here, because sometimes we do care. In this case, what did we say? We knew it was positive, but particularly the number was what? 16 minus 0, so 16 even. All right, so it's positive and a perfect square. All right, so we won't have to do the computation on the last one if we figure this one out correctly. So positive and a perfect square means what? It's going to go right through the number. So that's going to place C on, if you have a choice between 3 or 4, it's going to be 4. All right, so then through process of elimination is what I was going to say. I don't know. That's a word, but it's not the right one. Process of elimination, it would be D for 3. All right, and so you'd be looking at 64 minus, what is that, 52? So you get a result of 12, which is not a perfect square. So that would explain why this one doesn't go through the clean numbers. All right. So, and also you can go the other way around. It's a little nifty trick if you're thinking of a multiple choice question. Instead of actually finding the discriminant, and that's really kind of the point behind all of this, it's to tell you that you don't always have to figure out the discriminant to know what type of number the discriminant is going to give. So I would say something like, here's a quadratic equation, 2x squared minus 7x plus 14. Whatever, it doesn't matter what it is. What kind of roots will this discriminant have? Right? Or what type of number will the discriminant give? Like, will it be a positive and perfect square? Will it be negative? Will it be positive and not a perfect square? All these different possibilities. Look at the picture and see if it goes through a clean point. If it goes through 2 clean points, then you know that it has to be positive and a perfect square. If it doesn't go through 2 clean points, if it's 2 ugly points, then it's most likely positive and not a perfect square. I mean, it's possible it doesn't go through a clean point, but it or at least visually it doesn't, but it actually does numerically, because sometimes it's hard to see that it's going through 7/8 on a graph. 7/8 is a clean number. It just doesn't look like it would be a clean number when you graph it. All right. But most likely, if it doesn't go through a nice tick mark on a graph, it's going to be an irrational discriminant, or related to an irrational discriminant. All right? So the next little section, determine the number of real solutions for each quadratic equation, and if the value of the discriminant is positive, negative, or zero. So this is exactly what I'm talking about. All right? So in number 5, we know we have how many solutions? 1 real root. The discriminant, b squared minus 4ac, we want to know, is it positive, negative, or 0? It's got to be equal to 0. All right? And so that would be the same idea for which other problem? Number 8, same deal, right? So it would be true for this one and for that one. So I'm not going to write it a second time. All right. Number 6, let's take a close look at that one. Does it look like it goes through those points cleanly? It's a smidge off, right? So we're looking at 2 real irrational roots. We're giving more than the question is asking for, I guess, but it's good practice. The discriminant, b squared minus 4ac, is it going to be positive, negative, or 0? Positive. And just to really make sure that we're hitting the concept as well as we could, is it going to be a perfect square or not a perfect square? And not a perfect square. All right, so the last one, the last one that we're going to do is I think the easiest one. How many roots? None. 0 real roots. b squared minus 4ac, the discriminant, what's going on there? Positive, negative, or 0?
Negative.
Negative. All right. It's one of those topics, I know you experienced this a lot this year, and unfortunately this is not the end of feeling this way. It's one of those topics where you're just not going to see the point until you get to the topic where you see the point. You know, and unfortunately that'll be in a couple of years. You know, it's like, oh, why are we learning about this discriminant stuff? It'll be important. When will it be important? Well, not this year, not the next year, the year after that. And it's like, well, then why are we learning it this year? My answer to that is, well, it's really, really important. No, it's because it's in the curriculum and it could be on the exam and I have to teach it. That's what it is. If I had control over the situation, I would save this bad boy for right before you actually needed it. Because it's wonderful to know the nature of the roots. There's value in that, but I don't see how you can't get the same information just by looking at a picture. You don't necessarily need to know b squared minus 4ac. And I also kind of look at it like the computation of b squared minus 4ac. You know, like the justification of that is to give you a clue as to what the roots are going to look like. But in doing so, you're doing the hardest part of the quadratic formula. So why not just do the quadratic formula? If you felt like that when you're computing the discriminant, then you feel the same way I do, right? So, but there are topics down the line where this will become incredibly important. Like, oh my God, now I see why we learned this. Unfortunately, it's one of those situations where it's not going to be for a couple of years, right? And it stinks, but that's the way it is.